In 1938, three scientists in Berlin discovered that when they split a uranium atom, the energy released from the split could power a bomb. However, many problems had to be overcome first. When Einstein heard that the Germans might be able to make the bomb, he sent a letter to President Roosevelt in 1939, telling him about the new discoveries. This letter helped initiate the creation of the bomb, but work was very slow. New discoveries in 1940 and 1941 showed that creation was feasible and made the atomic bomb the top priority for the U.S. In December of 1941, the United States government launched the Manhattan Project. I am a researcher for the Manhattan Project. I am researching nuclear fission, or the splitting of an atom at its nucleus. I do not specifically know what they are going to do with this information. Yes, the element needed for nuclear fission is very hard to extract and is very similar to another isotope that is completely useless in nuclear fission. We cannot extract it through chemical means, and we have to use mechanical methods instead, which takes a very long time to do. About 120,000 people. Researchers would do extensive amounts of research and calculations. And because there was no prior knowledge on how to do anything like this, when they started, many researchers had no idea what to do. But eventually, as more and more discoveries were made, research was easier to conduct. The researchers were not allowed to share anything they were working on. They couldn't even share research outside of the labs with each other. The Manhattan Project was created in 1942 and officially ended in 1946. At its peak, there was 120,000 people working on it, and many of them didn't even know what their research was going towards. At most, 30 scientists knew they were making a bomb. This project was originally called the Manhattan Project because a lot of the research was originally based in Manhattan. However, after more discoveries were made, research was then moved to Oak Ridge, Tennessee, Hanford, Washington, and Los Alamos, New Mexico. Oak Ridge Laboratories provided a lot of uranium-235, which was the main element used in nuclear fission. It was found that this isotope is the best and most useful to use to power the atomic bomb. The immense destructive power of the atomic weapons derives from a sudden release of energy produced by the splitting of the nuclei of fissile elements making up the bomb's core. The United States developed two types of atomic bombs during the Second World War. The first, Little Boy, was a gun-type weapon with a uranium core. Little Boy was dropped on Hiroshima. The second weapon, dropped on Nagasaki, was called Fat Man and was an implosion-type device with a plutonium core. The Research Center at Hanford, Washington, produced a lot of the element plutonium-239, which was the main isotope used in the bomb dropped on Nagasaki. Uranium-235 and plutonium-239 were selected by the atomic scientists because they readily undergo fission. Fission occurs when a neutron strikes the nucleus of either isotope, splitting the nucleus into fragments and releasing a tremendous amount of energy. The fission process becomes self-sustaining as neutrons produced by the splitting of an atom strike nearby nuclei and produce more fission. This is known as a chain reaction and is what causes an atomic explosion. When uranium-235 atom absorbs a neutron and fissions into two new atoms, it releases three new neutrons and some binding energy. Two neutrons do not continue the reaction because they are lost or absorbed by a uranium-238 atom. However, one neutron does collide with the atom of uranium-235, which then fissions and releases two neutrons and some binding energy. Both of these neutrons collide with uranium-235 atoms, each of which fission and release between 1 and 3 neutrons, and so on. This causes a nuclear chain reaction, causing a nuclear bomb to explode. The research at Los Alamos, New Mexico was mainly based on the shape of the nuclear bombs, and it became the site for assembling most of the nuclear weapons that we used during World War II here in the United States. In order to detonate an atomic weapon, you need a critical mass of fissionable material. This means you need enough uranium-235 or plutonium-239 to ensure that neutrons released by fission will strike another nucleus, thus producing a chain reaction. The more fissionable material you have, the greater the odds that such an event will occur. Critical mass is defined as the amount of material at which a neutron produced by fission process will, on average, create another fission event. This project was such a secret that not even Vice President Truman knew what the Manhattan Project was making. He did, however, know of its existence, and he was actually the one who made the final call saying that we should drop the atomic bombs on Hiroshima and Nagasaki to help us end the war. Little Boy and Fat Man, the bombs dropped on Japan, utilized different elements and completely separate methods of construction in order to function as nuclear weapons. Little Boy detonated due to a fission chain reaction involving the isotope uranium-235, while Fat Man used plutonium's plutonium-239 form. Little Boy, the bomb that was dropped on Hiroshima, was powered by the uranium isotope uranium-235, in a process that didn't come easily to the many Manhattan Project scientists working on the uranium extraction and enrichment process. Most uranium found naturally in the world exists as uranium-238, leaving only 0.7% of naturally existing uranium as the uranium-235 isotope. When a neutron bombards uranium-238, the isotope often captures the neutron to become uranium-239, failing to fission and thus failing to instigate a chain reaction that would detonate a bomb. The first challenge of the project was thus to determine the most efficient way to separate and purify uranium-235 from the overly abundant uranium-238. Standard methods of separation could not be used due to the strong chemical similarity between the two isotopes. In order to avoid wasting time on one new method that could have later prove insufficient to produce enough uranium-235 to allow the atomic bomb to reach critical mass, General Leslie Groves consulted with lead scientists of the project and agreed to investigate simultaneously 4 separate methods of separation and purifying uranium-235: gaseous diffusion, centrifuge, electromagnetic separation, and liquid thermal diffusion. Once enough uranium-235 was obtained to power the bomb, Little Boy was constructed using a gun-type design that fired one amount of uranium-235 at another to combine the two masses. This combination created a critical mass that set off a fission chain reaction to eventually detonate the bomb. The two masses of uranium-235 had to combine with one another quickly enough to avoid the spontaneous fission of the atom, which would cause the bomb to fizzle and thus fail to explode. Powered by plutonium, Fat Man, the bomb dropped on Nagasaki, could not use the same gun-type design that allowed Little Boy to explode effectively. The form of plutonium collected from the nuclear reactors at Hanford, Washington, for the bomb would not allow for this strategy. The Hanford plutonium emerged from the reactors less pure than the initial plutonium extracted from Ernest O. Lawrence's Berkeley lab, instead containing traces of isotope plutonium-240, as opposed to the desired plutonium-239. Plutonium's 240's higher fission rate would cause the atoms to undergo spontaneous fission before the gun-type design could bring the two masses of plutonium together, which would lower the energy involved in the actual detonation of the bomb. Thus, a new design was required. Physicist Seth Nettermeyer at Los Alamos constructed a design for the plutonium bomb that used conventional explosives around a central plutonium mass to quickly squeeze and consolidate the plutonium, increasing the pressure and density of the substance. An increased density allowed the plutonium to reach its critical mass, firing neutrons and allowing the fission chain reaction to proceed. To detonate the bomb, the explosives were ignited, releasing a shock wave that compressed the inner plutonium and led to its explosion. On July 16, 1945, the Trinity test of the nuclear bombs was a success. Then, on August 6, 1945, Little Boy was dropped on Hiroshima, and 3 days later, on August 9th, Fat Man was dropped on Nagasaki. And even though many people objected to it, the atomic bomb and the Manhattan Project greatly improved our war efforts and helped us win the war.